Hello everyone, today we are going to discuss about enzymes. So enzymes are proteins that act as a biological catalyst, meaning they speed up the reaction without being used up. So another term here is the catalyst. So a catalyst is a substance that speed up a chemical reaction but is not used up by the reaction. So activation energy is the minimum amount of energy that is required to activate atoms or the molecules to a condition in which they can under they can undergo chemical transformation or physical transfer. So that amount of energy that is required to convert a substance into the product is called now the activation energy. Active site. Active site is the part of the enzyme where the substrate mole molecule binds and the chemical reaction takes place. So that part of the enzyme where the substrate comes unattached, so it is called the active site. Substrate is a molecule in which the enzyme react with. So this one is this the so it is like the kind of, so like for example the molecule or the micromolecule like carbohydrate, protein, lipid. So that substance that react with enzyme, so it is now called the substrate. Enzyme substrate complex is a temporary molecule formed when the substrate binds to the enzyme. So when the enzyme and the substrate combine, so it forms enzymes substrate complex product is the end result after the substrate bind to the enzyme. General properties of the enzyme. The general properties of enzymes are all enzymes are protein in nature. Enzymes accelerate the reaction by but do not alter the reaction equilibrium. Also, enzymes do not are not consumed in overall reaction. Also, enzymes required is very minimal, or they are required in small quantity. So the enzymes required in the reaction are in small quantity. Enzymes are highly specific for their substrate. So um, the enzymes here catalyze the specific reaction, not just all reactions. So they catalyze the specific reaction. So another property of the enzyme is that the enzyme possesses the active site at which the interaction with the substrate takes place. So as you have said there, active site is the part of the enzyme where the substrate takes place. So that is the a property of enzyme. Sources of enzymes. Sources of enzyme. So we have two sources of enzyme. Endoenzyme. These are the enzymes that function within the cell. Most of the enzymes are of this type. For example, the metabolic oxidase. So they work within the cell. Another type of enzyme is exoenzyme. So these are the enzymes that are liberated by the cells and catalyze the reaction outside the cell. So for these enzymes, these are the enzymes that are secreted by the cell or produced by the cell, but they work outside the cell. So a good example are the digestive enzymes like amylase, lipase. So most of them they are produced in the cell, but the action is done outside the cell. Chemical composition of enzymes. So as you have said earlier, that enzymes are protein in nature. So depending on the presence and absence of non-protein component with the enzymes exist in two forms. So those are simple enzymes and hollow enzymes. So simple enzyme is made up of only protein molecules, but not not bound to any non-protein molecule. So for a simple molecule, so this is the enzyme that is made up of only protein part or the protein molecules only. So good example is a pancreatic ribonuclease. Another form of enzymes is holoenzymes. So holoenzymes, these are the enzymes that are made up of protein part and non-protein part. So the protein part, is called apoenzyme, whereas non-protein part is called coenzyme. So when the apoenzyme and coenzyme combine, they form an holoenzyme. So this is now the product. So the protein component of the enzymes is called apoenzyme, and a non-protein component of a holoenzyme is called a cofactor. So in this cofactor, in an organic compound, it is called a coenzyme. If it is organic group, so it is called activator. So it is in two ways. Either if that non-protein compound is in form of organic, it is called a coenzyme. But if it is not, if it is in inorganic, so it is called activator. So this diagram here now shows the enzyme. So this is the protein part of the enzyme, the protein part. So it is called apoenzyme. While non-protein part here, so it is called a cofactor. So it is called a cofactor. A cofactor. So when the two combine, they form a holoenzyme. So a protein, non-protein and the protein part combine to form a holoenzyme. So here, this is now a holoenzyme that comprises of apoenzyme and a coenzyme or a cofactor. So this is now the substrate. So the part where the enzyme binds here is called the active site. So this is now the active site. Properties of enzymes. So let us look at the specific properties of enzyme. So the active site. Enzymes molecules contain a special pocket or the cleft called the active site. So the active site contain amino acid molecule that create a three-dimensional surface complementary to the substrate. The active site binds to the substrate, forming enzyme substrate complex. So enzyme substrate complex is converted to enzyme and product complex, which is subsequently dissociate to enzymes and product. So when the product, not the product, but when the enzymes and the substrate combine, it forms a substrate and the enzyme complex. So the product now dissociate, forming the enzyme and the product separately. So for the combination with the substrate, the enzyme is said to possess one or more active site where the substrate can take part. Another property is the enzyme turnover number. So this refers to the amount of the substrate converted per unit time. So the amount of the substrate that converted within a minute, so it is called a turnover number. Most enzyme catalyzed reaction are highly efficient and faster than uncatalyzed reaction. Another property of enzyme is that they are specificity. So they are specific for substrate. So regulation can be activated or inhibited so that the rate of product formation respond to the needs of the cell. Heterospecificity. Enzymes show the specificities of the only one specific groups of the substrate. So for example, urease urease catalysis the hydrolysis of urea only. So a good example of the enzyme is L-amino oxidase. So for L-alanine substrate specificity, enzyme catalyze the reaction with the specific substrate, cannot act on the other substrate. They are like lock and the key model. So for substrate specificity, so specific substrate is catalyzed by specific enzyme. So that one it is indicated by this diagram representing. So the key part represent the enzyme, not the enzyme, the substrate, but the log part represent the the enzyme. So that is now the property of enzyme, that is a substrate specificity. Another property of the enzyme is the reaction specificity. A substrate can undergo many reaction enzymes. For example, oxalic acid undergo different reactions. So there is a term called zymogen. Zymogens, it is an inactive form of the enzyme. So some enzymes are produced in nature in inactive form, which can be activated when they are required. Such type of the enzymes are called zymogens. Many of the digestive enzymes and enzymes concerned in blood coagulation are in this group. Example is pepsinogen. So this zymogen is from gastric juice. When it is required, so pepsinogen is converted into pepsin, trypsinogen. This zymogen is converted into pancreatic juice, and when it is required, it is converted into trypsin. So according to this diagram, according to here, so the pepsinogen is converted into pepsin by the help of hydrochloric acid that is produced in the stomach. So trypsinogen is converted into trypsin by the help of enterokinase. So trypsinogen and pepsinogen are the inactive forms, while pepsin and trypsin are the active enzymes. Now isoenzymes, these are the enzymes having similar catalytic activity, act on the same substrate and produce the same product but originated at different sites and exhibit different physical and chemical characteristics such as electrophoretic mobilities, amino acid composition, and immunological behavior. So classification of the enzyme. So enzymes are classified in 6 good groups. So the first classification of enzymes is oxidoreductases. So that's classes of enzyme catalyzing the reaction of involving oxidation and reduction. So transferases, enzymes catalyzing a transfer of a group other than hydrogen, such as methyl amino phosphate group. So this class of enzymes, so they catalyze the reaction that involves the transfer of one group, like for example methyl group, amino group, phosphate group, alkyl group. So those enzymes that catalyze the reaction that involve those transfer of those groups are called transferases. So another group is hydrolysis, enzymes catalyzing hydrolysis. So this enzyme is the enzyme that is involved hydrolysis. As we know, the hydrolysis involve the breakdown of the substance with the presence of water or involving water molecules. The third class is not the fourth class is lysases. Lysases. So the enzyme that catalyzed the removal of the group from the substance by a mechanism other than hydrolysis, leaving the double bonds. Isomerases include all enzymes catalyzing the interconversion of optical, geometric, or positional isomers. So the enzyme that involves that isomerism now, so that class of enzyme is called isomerase. So the last class is ligases and synthetases. So the enzyme catalyzing the linking together of the compound coupled to breaking of pyrophosphate bond in ATP or similar trinucleotides. Mechanisms of action of enzyme. The whole process begins with the binding of the substrate to the active site of the enzyme. The active site is a specific region of the enzyme which combines with the substrate. Change in the distribution of the electron in the chemical bond of the substrate, the reaction that leads to the formation of the product. So the product are released and the enzyme is ready to catalyze another reaction. So when the substrate binds to the enzyme, so it forms an enzyme substrate complex which is catalyzed to form the enzyme product complex, and finally the product is released and the enzyme is left behind to catalyze another reaction. So the mode of action of the enzyme, it is now represented in this diagram. It is represented in this diagram whereby the reaction that is involved enzyme, it is represented by the red line, and the reaction that is not used enzyme, it is represented by the black line. So the reaction, so if you look at the distance between here up to here, it is short, but the distance between here up to the black line, so it is very high. So if you calculate the distance between here and between the reaction with the enzyme and the reaction with the kinetics without any, so the one that is represented by the green arrows, so that one is now the activation energy. So the amount of energy, it has been reduced. So it has been reduced by the presence of enzyme. So it has reduced the amount of energy used to catalyze the reaction. Mechanism of enzyme action. As you have said there before, that the mechanism of enzyme action, it is like lock key model of the enzyme action, that implies that the active site of the enzyme is complementary in shape, so that its substrate fit the shape of the enzyme molecule and the substrate molecule should fit each other like lock and key. So the shape and the active site of the enzymes are complementary. So that so for this mechanism, it is just represent the action of the key and the lock. So the lock represents the key, while the key itself,